Alright, another 793. This is a B model. The blower, when you turn the fan on, this is your settings. There's off, low, medium, high for the heat side of it, and then the same for the AC side, low, medium, high. Say the blower doesn't work, it pops the breaker only on high.
634 to 3M.
So we'll get this dash all apart, and then we can see if we can find the root cause so we can repair that. So let's get into it. All right, we've taken the dash panel off. These bolts here, these are all T30s. And then we've just removed the filter down here in the bottom as well. This is our resistor right here. This is what's going to control our fan speed. So basically a lower speed just has more resistance before that electrical current can get to ground, which means there's less amperage available to spin the fan, which makes it spin slower. It's a dual fan setup. So we'll get the test light out. We'll just do a quick and dirty test. We can check. All right, we've reset the breaker. Turn the fan back on. So you can see the current draw there. You can watch the test light dim when I turn it on high. That's back off. Once again, we only have this motor plugged in right here. This motor is unplugged. So now, with very little troubleshooting, literally we've been at this for 10 minutes, we already know 100% confirmed this motor's faulty. But we're not just going to blindly put a motor in it, right? Let's tear this one out of here. Maybe we got some debris in here that's holding it from spinning, and then that causes it to overamp combined with the amp draw of this other motor. These bolts in here, guys, everything inside the cab and on the engine on these haul trucks is standard. Everything else on the truck is metric. These are just little 7/16 bolts. Now I did feel this fan, you guys can't hardly, yeah, you can see it in there. But I did feel that it was bound up a little bit. I just kind of moved it around. It does move freely now, but we're not done there. We're still going to take this out of here. We want to know what was in there. We just need to know what's the root cause. We want to identify the one problem that's causing the issue and fix just that, right? We don't want to just blindly throw parts at anything or just guess and change everything and then accidentally fix it. So that's what we're doing now. I'll finish yarding this apart, and then we're going to investigate it. Well, we made a mistake here, guys. We didn't have any reason to take this off. It's been quite a while, actually, since I've done a blower motor. But nonetheless, it only set us back about 6 or 8 minutes tops to put this front end back together. All of our work will be inside the cab. Well, look here, guys. This is what's making our fan fight us. You see that? We got some trash in there. Something's coming apart. And it's between the squirrel cage and this blower housing, or the ductwork, or what have you. But that's why it's not wanting to come out. So we definitely made the right call. Even though I freed that fan up, we made the right call to continue tearing this apart. We want to know what's going on in there. So I'll bring you guys back once I make some headway on this. Making some headway now. Boy, that came out violently. Look at this, guys. This is all pieces of the ductwork, which has a paper towel smashed into it. This is what should be there. Well, we got all the debris and stuff out. And I just want to check this fan out. So I'm looking for any end play where maybe this squirrel cage part of it moves in and out this direction. Nothing there. And then also any side to side play, if I could twist it kind of this direction while holding the motor still. No, it feels in good shape. So we'll put it back together. We got 2 of our 3 mounting screws back on there. Did you guys happen to see where that other one went? Oh, there it is. Right here, look at hiding back there. I had him in a pile right here. That's why I was asking. Maybe you guys kicked it. No problem. Time for the big moment of truth. Make sure we got power. We do. Let's see if it pops our breaker. Both motors are plugged in right now. That's it. Nailed it, guys. Something else we could take away from this, guys. So an electric motor, under normal circumstances, normal operating conditions, it's going to have its maximum amperage draw when the motor is stopped and starting up. You know, when you first turn it on. That's under normal circumstances. It's going to have the highest amp draw until the engine gets up to RPM. Then the amp draw is then going to fall off. It won't draw as much. Now, if while it's running at max RPM, if you start to load up on it or provide some sort of resistance, think like an electric drill and you're leaning real hard on a drill bit as you're trying to drill. So, of course, that increased load is going to increase the amp draw. And in this case, the motor was basically just locked up with all this stuff from the vents. Wouldn't even let it get started. But I guess, you know, one other thing to take away from that is it also highlights the importance of having a properly sized fuse or circuit breaker on any electrical circuit, right? So it, under normal circumstances, that never pops. Yet it had enough leeway that as the motor kept trying to get going, it would overamp and pop the breaker. Now imagine if that breaker was just, say, 5 amps bigger. You know, then this truck may have ran the entire time without ever popping that breaker. Meanwhile, the wiring going to that motor starting to get hot. That creates resistance, which creates more heat. And, you know, you could potentially have a fire or something catastrophic could happen there. So that's also, you know, I guess that highlights also the importance of, you know, when you make a new circuit or I make a new circuit, say I'm going to install freaking lights on a side-by-side or something, you can either use math, just look at the ohms on the lights or the wattage. You can use Watt's law or whatever to figure out your amp draw, and then you want to add about 20% capacity. So say your lights are going to draw 8 amps, put a 10 amp fuse, you should be good. But how many times you guys see people or know people that, oh, put some lights on, whatever, wired directly to the battery, so if there's ever a short, the wiring now becomes the fuse, which is, that's never a good thing. So just something else, I just wanted to highlight that, you know, the importance, I guess, of sizing your electrical circuits appropriately. Anybody can just smash a wire onto a battery and put some lights on it with a switch, call it good, but the fuse is designed to protect the wiring, not the light, the wiring. This is everything that came out of that blower motor housing. This is all the pieces of that vent, broken plastic. And finally, my rework. get this all buttoned up, guys. This truck is done.